If you look at this graph right here, is the degree going to be even or is it going to be odd?
Odd.
So this graph right here, so we have some people saying the degree is odd. How do they know that it's odd?
You want us to draw this graph?
Nope.
And it's negative.
Oh, that's wild.
Why is it odd? I agree that it's odd, but why?
That's shape.
The ends. I have one arrow that goes up, and I have one arrow that goes down. You see it? So evens either go up, up, down, down, or odds, they have one of each. Now, when I look at this odd graph, does it have a negative coefficient or a positive coefficient? Negative, because the left end goes up, the right end goes down. That has a negative slant to the graph. You guys see it? Okay. So far, you are not writing anything. I'm just keeping track of this stuff for us. Okay. You are not writing anything down yet. Okay. All right. So where do you see some x-intercepts? I see -4, right? X equals -4, x equals 0, x equals +4. Okay. So if we start writing our equation, I'm going to put y equals, so you can go ahead and write this down, y equals. We can see a negative coefficient, right? We know that the graph definitely has a negative. That's why it has an up arrow at the left and a right arrow at the bottom. So we're going to put negative in the front. And then how do I put an x-intercept of -4 inside parentheses? X plus 4. Now, at the -4, what multiplicity is that? Can you tell? It goes straight through the point. That's a multiplicity of 1.
Quick question.
Mm-hmm.
So if it's an x-intercept of -4, why does it mean positive 4?
Because when you look at your factors, it's always the opposite sign. All right, the next one is an x-intercept of 0. Where does that show up? How do we write that? You could write x plus 0, or you could just write x. And typically people put that in the front, so we're going to put that in the front. And what's the multiplicity at 0? It goes through, yeah, it's a 3, because if you look at it, here's 0 right here, it does not go straight through 0. It squiggles through 0. That's what a multiplicity of 3 does. They squiggle as they go through that point. So we have an x-intercept of 0, and we squiggle as we go through it, so that's going to be a multiplicity of 3.
So if it's a 1, can it go this way and this way too?
Yep. Yep. So when you look at it, you just have to say, like, if I cover everything else up, that's a straight line going through that point, so it's a multiplicity of 1. So the last intercept was 4, so x minus 4, and then it goes straight through that, so that would be to the 1 power. Now those 1 exponents you don't have to write as a 1 if you don't want to. If you want to do it right now because we're just beginning, just to make sure that we don't forget about it, then that's totally fine. Just to make sure you know the difference between a multiplicity of 1 and of 2 and of 3. Okay, how's that? How's your brain? Yeah. Don't worry, I got a lot of pictures. I got a lot of graphs. Yes.
You said that line goes to -4,
Uh-huh.
but that is not what
But if you cover it up, it is kind of curved, but it is definitely not doing this. It's not an S curve. It is mostly straight as it goes through -4. A multiplicity of 2 is a parabola. So this is definitely not a parabola. Right? There's a parabola down here, but if you look at the actual x-intercept, that is definitely not a parabola right there. Because an x-intercept that looks like a parabola would be like, here's an x-intercept, there's a parabola. A multiplicity of 11 would look like an S curve. So a multiplicity of 1 looks like a straight line. A multiplicity of 2, 4, 6, 8, 10, 12, all those are going to look like parabolas. And then a multiplicity of 3, 5, 7, 11, 13, 15, those are all going to be the S curves. Yeah. All right, so let's try the next one. So if you look right there, okay, is that going to be even or is it going to be odd? Even. It's going to be even. How do we know it's even? You guys got that real quick? Yeah, because the arrows go the same way. Okay, so when we look at this, we already know that the degree is even. Is it going to have a positive coefficient or a negative coefficient?
Positive.
Positive. How do you know it's positive? It goes up, up. Okay. What, now, the labels on this are really, really bad. So I think with the other class, we figured out it was like, oh gosh.
Isn't it one?
It kind of looks like 1, 2, 3, 4, 5. 5 spaces is -2. That's kind of confusing. What?
5.9.
Yeah, that's. Ugh. Okay, I'm gonna scribble these out. We're gonna make different numbers here. We're gonna pretend it goes by ones, okay? Yeah, if you go by halves, it's still kind of funky. Let's just pretend it goes by ones because the labels are not very good on this one. Okay, so if it goes by ones, we got 1, 2, 3, 4. So we got -4. 5, 6, 7, 8, 9. And then 1, 2, 3, 4. 5, 6, 7, 8, 9. Oh, it's the same. Okay. All right, so when we write the equation, what is the multiplicity for each of those? 1. Can you guys see how it's 1?
Yeah.
So if I cover up everything else, it goes straight through. It goes straight through. It goes straight through. It goes straight through. All right, so we got y equals, and how should I write this? And then
Is that a negative?
does it need to have a negative in the front? That's it. What's the degree of this graph?
1. Oh, sorry.
4. What was the degree? What was the degree of this graph? 5.
Where are we getting
Yeah, where are we getting the degree from?
Right there. 3 plus
3 plus 1 plus 1 makes 5. Down here, all of those would have been a 1. So it's 1, 2, 3, 4. Just forgot them all up. Okay. We're going to try this crazy looking one right here. So you can't see it very well, but that's... Okay. Is this graph even or odd? Even.
Whoa.
Wait.
Okay, so we said the degree is even. How do we know? Yeah, the two arrows are the same, up and up.
So is that one a parabola?
Yeah, this would be a parabola. So what's multiplicity right here?
3.
2. Multiplicity of 2. Parabolas have multiplicity of 2. Alright, so even, is there a positive coefficient or a negative coefficient? Positive.
Wait, do we always write
Oh, we have a nice arrow.
Again, how will we know if it's positive?
Because the arrows both go up. If it was negative, they would both go down. Okay.
That bothers me.
What else can we see about the graph? The x-intercepts, we got... Okay, so y equals, and how could we write this? Okay, but we have some multiplicities in there, right? So we're going to have to put some exponents in here. This is a multiplicity of 2. It's a parabola, it's a multiplicity of 2. What's the multiplicity of this one right here? 3, yeah, so it goes through it, but it squiggles as it goes through, so that's a multiplicity of 3. What's the multiplicity over here? That would be a 2. It would be another 2. So it's a parabola, it's just a really fat one. But you can see that it still has a parabola shape. So this is a multiplicity of 2. And then what's the multiplicity on the last one?
1.
So this is a multiplicity of 8.
So this graph, we wouldn't say multiplicity of 8. We would say a degree of 8. Do we see where that degree of 8 came from? So 2 plus 3 is 5, plus another 2 is 7, plus the 1 on the end is 8. Alright, so degree of 8. Okay. Alright, let's look at this next one. Ooh. Is this one even or odd? This one is odd. The degree is odd, and it's positive. How did you know it was positive?
Because the right one goes up, the left one goes down.
Yeah, so if we look at this, it goes down to the left and up to the right, and that looks like a positive slope. So I'm kind of ignoring the squiggles. If you guys have noticed that, I kind of ignore the squiggles in the middle, and I just think about overall what the shape is, and that tells me positive versus negative. All right, so what are the x-intercepts here?
Negative 5.
Yeah, that's kind of hard to tell. Maybe negative 2?
Nah, that was like negative 1.
What is that?
Yeah, negative 2.
I'm going to say negative 2.
What is that?
And what about this one over here?
Negative 3.
Negative 3?
I mean
Positive
positive.
3. Woo. All right, and then what's the multiplicity for each of those? 1, yeah. Straight through, straight through, straight through. All right, so what are we going to write? X plus 5.
X plus 2. X minus 3.
Why are we adding 5?
We always do the opposite, remember, because when we look at things in factored form, to be able to get the answer, you have to do the opposite. So if we're putting it back in factored form, we're going to do the opposite when we put it back. All right. Can I move this one? All right, what about this one right here? So odd. How do we know this is odd? The arrows go opposite ways. Okay. It's positive. It's odd. It's positive. Okay, I'm not going to write the equation for you. I want you guys to go ahead and write it on your paper.
What is that?
Have you seen Gary without his shoes? Okay.
So go ahead and write the equation down.
Oh, that hurts my eyes.
If it squiggles through, it's going to be real obvious that it squiggles through.
So it's 1.
So the 4 and the 7 are both ones.
3 is 2. Is it 2?
That's a coefficient of, or a multiplicity of 2.
I think, I don't know.
Right here, you see a parabola right here?
No.
Yeah. All right, what did we get? What did you guys get?
X plus 3.
X plus 3 to the third. And then x
Minus 4 to the
x minus 4 to the 1. And x minus 7 to the 1. Yeah. Yes. We are basically just going to say 1, 2, and 3. We're not going to be more precise than that.
Miss.
Later on, our will have to be like 7, 8.
Yep, 3, 1, 1. Sorry, this sticky note is a weird color. Okay, and then go ahead and write down the equation for this graph. So here's -1, there's -2, -3,
These should be like
-4,
Rorschach tests.
+1, -2.
What?
So write the equation out.
Ms. Rice,
Yes.
could you send Cameron Warren to sign up?
Yes.
Thank you.
What's the weirdest thing I've ever seen you say?
I'd have to think and make you a list. Because there's a lot. Alright, we're awfully chatty. Does that mean we're done? Okay, so we got. You were one of the chatting people. Y equals x plus 1 to the third, okay.
Does it matter which way I put it in? Oh, never. I guess it does. It doesn't.
I can.
Oh shit.
Oh yeah, so since you said any odd number, like 3.
So any odd number multiplicity is going to look the same, but when we write our equations, we're just going to use 1, 2, and 3. Okay. I almost agree with this equation. It's missing something. A negative. It needs a negative in the front.
If that happens,